Hello, we are going to review some simplifying radicals. So this is usually a concept that students usually struggle with this quite a bit, but there is really no reason, if you know your multiplication table, that should not be a big deal at all. So when we are looking at simplifying a radical, and here we're only going to deal with square roots. I didn't do any cube roots or anything above that. So we're just going to deal with square roots, because once you understand the square roots, the other ones will be similar anyway. So when we're simplifying a square root, what we're trying to keep in mind is that we're trying to undo something that has been squared, right? So what do I mean by that? If I take 5, for example, and I square it, that will be equal to 25. So when I want to undo that square that I've done here, when I have my 25, let's say I don't see that anymore, I just see the 25, and I want to undo what has been squared. To undo that, we're going to take a square root, right? So taking a square root will undo the squaring, but to be able to do that, so that will just be equal to 5 back to where we had it at first, right? So to be able to do that, we need to figure out what is the perfect square here. What is the number that has been squared? Well, 72 is obviously not a perfect square. So what do I talk about when I say perfect square? 25 is a perfect square, because 5 times 5. So why do we call them perfect square? Because remember that the area of a square is being found by multiplying, let's say this is side A, and because it's a square, that's going to be side A also. The area of a square is found by doing A times A, which is A squared, right? You can see my purple marker, it is worn out. So to find the area of a square, I'm going to multiply the sides, because the side will be the same since it's a square. And so the area will be A squared. That's what we call a perfect square. So let's say we had a square with a side 3. Well, if this side is 3, then that side is 3 also, right? And so the area will be 3 times 3, which is 9. 9 is a perfect square because it's the area of a square. Okay, that's what we call a perfect square. So now that you have the idea, we need to figure out perfect squares. Well, 72 is not a perfect square, so we need to ask ourselves, what can we multiply to give us a 72? So we want to multiply two numbers that would give us 72, but one of those numbers has to be a perfect square, okay? So which one of those, which numbers could I multiply to give me 72, and one of them is a perfect square? Well, 72 is the same thing as 36 times 2. 36 times 2 is 76. And 36 is a perfect square. 6 times 6 will be what has been squared to give you 36, right? So when I decided what numbers I want, then I'm going to say, okay, well, square root of 72 then is the square root of 36 times 2, right? Okay. So now we're going to take the square roots, right? So the square root of 36 is just going to be a 6. So it's coming outside, not in the square root anymore. But 2 is not a perfect square, so that has to stay in the square root. So the square root of 36 became a 6 on the outside. The 2 is not a perfect square, so it has to stay. And there we go. So let's do that whole process again, and let's talk it through one more time. We are going to look for two numbers that we're going to multiply. One of them has to be a perfect square. So what times what would give me 200? Well, 100 times 2 will give me 200. And 100 will be 10 times 10. So I'm going to rewrite my square root of 200 as a 100 times 2, and the square root of 100 becomes a 10. So that becomes 10, and then the 2 has to stay, so square root of 2. Okay? 6. Well, 6 is 1 times 6 or 2 times 3. None of those are perfect square, which means this is as simple as it can get. We can't simplify that any further. Square root of 36. Well, we know that the square root of 36 is just going to be a 6, right? Not a square root of 6, just a 6. So we have a 5, square root of 6, and then plus 6. We can't combine those because they are not like terms. This has a square root of 6, this one does not. So that will be your final answer right there. Alright, 18. What can be multiplied to give us an 18? One of them has to be a perfect square. 9 times 2 will give me 18, and then the square root of 9 becomes a 3, right? The square root of 9 will come out as a 3. Because I already had a number on the outside, when I take that 9 out of the square root, I need to multiply with the number that was already there. So 6 times 3 will give me 18. And then what's left over in my square root will be that 2, so square root of 2. Now, before I go to this one, I want to mention something. This 18 I have on the outside is not the same 18 as this one. Forget about this one for a second. Look here. This 18 is 9 times 2. 9 times 2 is 18, and that's in a square root. Square root of 9 is 3, and then the 2 stays in the square root. This 3 is going to have to be multiplied with what was already outside of the root, right? Because that was a multiplication here. So 6 times 3 is 18. This is what gives us this 18 on the outside. Those two numbers multiplied, right? Okay? Now, let's look at this one. 50. What can we multiply to give us a 50? One of them being a perfect square. Well, looks like 25 times 2 would work. So I'm having that in a square root. The square root of 25 is 5 on the outside. I already had a number, so I have to multiply those two. 3 times 5 is 15, and it was a plus between them, so plus 15, and then that 2 stays, so square root of 2. Unlike here, when those two are not like terms, now I have two like terms here, because I have a square root of 2 and a square root of 2. So what is that telling me? It tells me I have 18 square root of 2's plus 15 square root of 2's. How many square root of 2's do I have altogether? Well, 18 plus 15. So what's 18 plus 15? That would be 33. So I have 33 square root of 2's. There we go. Okay. What can I multiply to give me a 75? One of them has to be a perfect square. Well, it sure looks like 25 times 3 will give me 75, and 25 is a perfect square. That will be coming out. Square root of 25 is 5. There is no number in front here, so just a 1. 1 times 5 is 5, so we're going to have a 5. And what's left inside will be square root of 3. Okay? Do the same with the 48. So put your plus down here, and now do the same. 48 will be what times what? One of them has to be a perfect square. So that looks like it should be 16 times 3. And the square root of 16 is 4, so it comes on the outside as a 4. We already had a 2 on the outside, so we have to multiply those two. So 2 times 4 is 8. And what's left inside is the square root of 3. And then this is already as simple as it can get, right? We cannot simplify 3 square root of 3, so that says minus 5 square root of 3. Okay? We have all of our square roots simplified. Now we look, are they all like terms? Well, yes, they're all square root of 3's. So how many of them do I have? I have 5 of them, plus 8. that will be 13, minus 5, so that will be back to 8, right? So I have 8 square root of 3's. Okay? Keep going. 27. What times what will give me 27? One of those numbers has to be a perfect square. Well, 9 times 3 is 27, and 9 is a perfect square. Square root of 9 is 3. There was already a coefficient in the front, so we need to multiply those two. So 2 times 3 is 6, and what's left is the square root of 3 here. Plus, okay, 32 would be what times what? One of them has to be a perfect square. 32 will be 16 times 2, and the square root of 16 is 4, so that comes out as a 4. There was no number in the front here, so just a 1, so 1 times 4 is 4, and then what's left inside is the square root of 2. And now we have to check. Those square roots are simplified, but they are not the same. So those are not like terms, so we cannot combine them. This will be your final answer. How about with a variable inside? For the numbers, you do the same thing, no difference. You won't look for something that when you multiply, it will give you 12. One of them has to be a perfect square. So 4 times 3. Square root of 4 is 2, and then the 3 stays inside. There is no number in the front, so 1 times 2 is just 2, so we're going to have a 2 here. And the 3 is going to stay in the square root. The x to the 4th. So remember we said earlier that a square root undoes something that has been squared, right? Those two are inverse operation of each other. We usually don't write the square here, the little 2, when it's a square root. We will just write it down if we would have a cube root, for example. Cube root of 8 would be what cubed would give me an 8, and that would be 2, right? 2 cubed would be 8. So when it's anything but a 2, we have to write the index. But when it's a square root, we usually don't write it. Like, see, nowhere did we write it, right? Because it's the most common one, so we don't write that too. But I'm going to put it there just to show you what's happening. What we want is x to the 4th in a square root. Well, how many 4 can you put into, how many 2 can you put into 4? 4, so take that 4, divided by 2, what would we get? We will get a 2, right? So that x comes out of the square root squared. That will be your answer. Okay? The square root of 25, well, we don't have to break that into two things that multiplies because 25 is already a perfect square. That will be 5. Now, the x here will be x squared times x, right? So the x squared comes out of the square root. How many 2 can you put into 2? 1. So the x squared comes out of the square root as an x, and this one stays inside. So we have 1 out, 1 stays in. Here we have a fraction, 20, and the 50, is going to be something that we have to think about. What can we multiply to give us a 50? So 25 times 2, and then the 25 is my perfect square that will come out as a 5, right? The square root of 9 is just going to be a 9, is going to be a 3. And then here I have x to the 4th in a square root. So how many 2 can I put into 4? That will be 2. So all of that, the 50 will go to 5 square root of 2. The x to the 4th will become 4 divided by 2 is 2, so that will be an x squared. Let's write that the proper way. So we have the 5, the x squared, the 2 that stays inside, and then the square root of 9 will be 3. Okay. This one was a little bit more complicated, but I am pretty sure you can handle it. Okay, good luck with your review. This was the last video.